If f is a polynomial function, then the values of x for which f of x is equal to 0 are called the zeros. So remember, we've been talking about zeros in the other sections. These values of x are also called the roots or solutions, or we call them x-intercepts of the polynomial function. The statements listed below are equivalent. If x is equal to a, we say that's a zero of the function f. X of x equals a is a solution. X minus a is a factor, and a comma 0 is an x-intercept. So these all mean the same thing. A polynomial function of the nth degree is a product of n factors, so it would have at most n roots or zeros. The graph of a polynomial function of degree n must have at most n minus 1 turning points. So what this is saying is if your degree is 3, then you should have 3 zeros. Okay. So for example, given the polynomial f of x equals x minus 2, x plus 1, x minus 4, determine the y and x-intercepts. Determine the maximum number of x-intercepts and turning points. So the first thing we want to do is find the x-intercepts, which are the zeros. So to do that, we're going to let y equals 0 and solve for x. So here's my function. And I'm going to let y equal 0. So I said each factor equal to 0, since it's already factored out. And I solve for x. So I'm going to add 2 on both sides. So I get x equals 2. Subtract 1 on both sides. So I get x equals negative 1. And add 4 on both sides. So we get x equals 4. Okay, so these are called our zeros, or x-intercepts. The y-intercepts, or the y-intercept, is we let x equals 0 and solve for y. So if x is 0, we get 0 minus 2, 0 plus 1, 0 minus 4. 0 minus 2 is 2. 0 plus 1 is 1. 0 minus 4 is negative 4. Multiply it out. 2 times 1 is 2 times negative 4 is negative 8. So this is our y-intercept. So notice here that our degree for this polynomial, if I was to multiply x times x, I get x squared, and then x squared times x is going to be x cubed. So my highest degree is going to be 3. And I encourage you to multiply this entire thing out, and you'll see that we still have a degree of 3. And our leading coefficient, well, this is a 1 times a 1 is 1 times a 1 is 1. So our turning points is going to be found by using n minus 1, where n is the degree. So we say degree minus 1. In this case, our degree is 3, so we say 3 minus 1 is 2 turning points. So it's going to have at most 2 turning points. So it could have 1 turning point, anything less than 2. Less than or equal to 2. The number of zeros was 3. 1, 2, 3. Notice the degree is 3. So we should have had 3 zeros, which we do. Okay, so let's go ahead and find the behavior, even though it doesn't ask us to. So remember, the behavior is found using this table. So since the degree is odd and you have a positive leading coefficient, so the degree is odd, and positive leading coefficient, it's going to behave like letter C. So we say that the graph rises right and falls left. Okay. So we look at the graph, this is the information we have for it so far. We have the zeros, x equals 2, that's right here, x equals -1, and x equals 4. We have a y-intercept of 0, -8, so somewhere down here. We know the behavior, it's going to rise to the right, and it's going to fall to the left. So everything in between, we don't know yet, but we will figure this out in the next sections. Find all the real zeros and determine the maximum number of points. So again, here we have f of x is equal to x cubed minus 12x squared plus 36x. So we can find the zeros first. To find the zero, that's the x-intercept, so we're going to let y equals 0 and solve for x. So here, in order to solve this, we need to try to factor this. So we always check if there's anything in common to all three terms. This has x cubed, x squared, and an x. So I can actually factor out an x. So if I take an x out of here, I'm going to be left with x squared. If I take an x out of here, I'm left with 1x. And if I take this x out, if I factor it out, I'm left with 36. So if we multiply x times x squared, x times -12x, x times 36 is going to be this polynomial. After that, you can see that in the parentheses right here, this is quadratic, so you have two options to solve this. Number one, you can see if it factors, or you can use the quadratic formula if you prefer to use the quadratic formula. I always like to try and factor, and if it's not factorable, then I go ahead and use the quadratic formula. So 36, I need two numbers that when I multiply them will give me 12. So that's going to be 6 times 6 is 36. If I add 6 and 6, I get 12. I need this to be a negative, and this is a positive, so the signs will be the same. So -6 times -6 is positive 36. -6 plus -6 is -12. So now I can set the factors equal to 0. And so here we get x is equal to 6 and x is equal to 6. So I have 3 zeros. Notice my degree was 3. That means I should have 3 zeros, which I do. Although these are the same, we still count them individually. And let's go ahead and look at the behavior. This is the end behavior. So my degree is 3, which is odd. My leading coefficient is 1, which is positive. So my behavior is going to be that the graph rises right and falls left. Okay, so again, for this problem, if I was to graph it, the information I have right now is that at x equals 6, we have a 0. And at x equals 0, we have a 0. And if we were to find the y-intercept, it would be at 0, 0 as well. So we know that the graph is going to rise to the right and it's going to fall to the left. So in later sections, we'll figure out what goes in between. Let's go to the next page. Determine the solutions of x to the fourth minus 4x squared. Determine the maximum number of zeros and turning points. The number of turning points for this one was the degree minus 1, so the degree is 3. So we have 2 turning points. At most 2 turning points. Example 6, determine the solutions of f of x equals x to the fourth minus 4x squared, and determine the maximum number of zeros. So whenever they ask for solutions, that still means the same as zeros and x-intercepts. So we're letting y equal 0 and solve for x. So here's my function. So we get 0 is equal to x to the fourth minus 4x squared. I can factor out an x squared. So if I get an x squared out of here, I get x squared minus 4. Try to factor this parentheses. This is perfect squares, so I'm going to have x minus 2 and x plus 2. So this x squared can be the same as x times x. And I go ahead and write it this way so that we don't forget that there's actually 2 here. So now I can say 0 is equal to x, 0 is equal to x, 0 is equal to x minus 2, and 0 is equal to x plus 2. So my zeros are going to be x equals 2. Subtract the 2 here, x equals negative 2, x equals 0, and x equals 0. So you want to be careful here, because at this step right here, if you had said 0 is equal to x squared, 0 is equal to x minus 2, and 0 is equal to x plus 2, then to solve for x here, we take the square root. So we get x is equal to 0, x is equal to 2, and x is equal to negative 2. So here we're only listing it once, but in reality there's 2 zeros at x equals 0. And so if you take the square root, just remember that there's actually 2 answers here. You get the plus and the minus answer. The turning points, the degree is 4 minus 1, so we have at most 3 turning points.